Today we're going to be looking at the volume of a hemisphere and a sphere. So let's first of all let's draw a little note in our book. So write this title down in your notes: volume of a sphere and hemisphere. We're going to write down what the volume of a sphere and hemisphere is. So the best way to do this is to draw a circle. Better than me. Yeah, draw a circle, and then if you do like a dotted oval around here, and then go from the center to the edge, and this is the radius, like so. And then the formula for the volume of a sphere is equal to 4/3 pi r cubed. So get that down first of all. Now we'll talk about a hemisphere in a little bit. Hemisphere is obviously half of the sphere, so you need to divide it by 2. But we'll get that one down for now, and then we will crack on. So just pop your hand up as everybody's got that first part down. Good, keep your hand up if you've got it, just so I can see. Brilliant. Brilliant. Okay, so let's move on then. Pop your hand down for me. So, the sphere below has a diameter of 34 centimeters. So first I'm going to draw that in. So make sure you're writing these in your notes. Remember, the best way to do it is to draw a circle like this, and then just do a little dotted oval around the middle. And this time they're saying that the diameter is 34. Like so. Give your work out the volume of the sphere. So the first thing I'm going to do with this is when I'm going to write down that diameter is equal to 34 centimeters, which means that my radius is going to be half of that, which is going to be equal to 17 centimeters. Nice and straightforward for this first one. It is example 1, yeah. So this is example 1. So then the formula, they do actually give you the formula for the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. We sub in what we know, so the volume is equal to 4/3 pi times by 17 cubed. Making sure we're using mini brackets to substitute in. And then we're going to type that into our calculator. Brilliant. So that's 20,579.5 centimeters cubed. Brilliant. Thank you. Alright, so have a go at this one on the left hand side. I know it's quite easy, but have a quick go, and then once you've done that, pop your answers into the chat.
Sir, I can't see the chat.
Okay, I'm going to start going through this one on the left. This one here, they've told you actually the radius is equal to 4 centimeters. So my radius is equal to 4 centimeters. My diameter is equal to 8 centimeters. I don't need to know that, but it's worth writing down. So my volume is equal to 4/3 pi r cubed. So my volume is equal to 4/3 pi times by 4 cubed. So my volume is equal to 4 to the power of 3 times by 4 divided by 3 times by pi is equal to 1 decimal place. So the full answer is 268.08257. So we're going to need to round this up after 1 decimal place, which means it's going to be 268.1 centimeters cubed. Brilliant. Hopefully everyone got that. So there's our two answers. Brilliant. Okay, let's have a look at this one now. This is a hemisphere. So it's not that much tricky. It's not that much harder, to be honest. The only difference is we know that this is half a sphere. So we'd probably find out the formula for a full sphere first, and then halve it. Or sorry, find the volume for a full sphere first. So let's first of all write down. Well, I'll show you how to draw this one actually first. So if you draw a little oval shape like this, and then you can just go over like that, and there's your hemisphere. Or you could do it the other way, draw one like that, and then an oval on the bottom. Either way, you'll be fine. So, it says here that the radius of my hemisphere is equal to 5 centimeters. So the first thing I'm going to do, I'm going to work out the volume. So I'd write down what the formula for the volume is. Volume is equal to 4/3 pi r cubed. So my volume is equal to 4/3 times by pi times by 5 cubed in this one. So 5 cubed times by 4 divided by 3 times by pi. So the volume of my full sphere, and I shall probably say that actually. So let's just make it really clear what I'm doing here. So this is volume of the full sphere is equal to 523.59877. Continuing on. So for a hemisphere, I need to divide this by 2. So 523.59877 divided by 2. And that gives us the volume of the hemisphere is equal to 261.7993, continuing on. And if we want this to 1 decimal place, we're going to put our line here, and this means we're going to round up. So that's going to be 261.8 centimetres cubed. Brilliant. So get that one down in your notes. That'll be example 2. And then once you've done that, have a go at the one on the right-hand side. Be careful with this one. There's just a little note here. It says that the diameter is equal to 36 centimetres this time. Brilliant. Some people have got it already. So my diameter is equal to 36. So my radius is equal to half of that, which is going to be 18 centimetres. So my volume is equal to 4 over 3 pi r cubed. So my volume is equal to 4 over 3 pi times by 18 cubed. Let's work that one out. So 18 cubed times by 4 divided by 3. Now I'm using my phone for a calculator now, which I wouldn't suggest. I'll get that sorted for next time. So there's our answer to that. Don't forget we need to find out the volume of the hemisphere, which is really important. So my hemisphere is going to be this divided by 2, which is equal to, most of you got that anyway, 12,214.5 centimetres cubed. Nice and straightforward. Brilliant. Super. So, we've done sphere, we've done hemisphere, so let's step it up a little bit now. So we're going to look now at the surface area of a sphere. Now, so the surface area means, it doesn't mean the space inside of this, it means the space all the way around the outside of this, and it's probably worth putting this back at the start as well. So at the start of here, I've got my surface area, which is equal to, now the surface area of this is basically, the best way to imagine it is if you were thinking about potentially a football, the amount of material that you'd need to make that football. So obviously all inside it's just the air, isn't it? Whereas you do need to actually have some kind of material to make that football, and it's the material that we're thinking about for the football rather than the air inside it. And the formula for the surface area of a sphere is equal to 4 pi r squared. We'll go back to that in a second. So the surface area for that, for a sphere, is equal to 4 pi r squared. So get that one down, and then we're going to continue, have a go at this one here. So the sphere has a diameter of 36. Calculate the surface area this time of the sphere. So straight away, let's write down what this diameter is, 36. So my diameter is equal to 36 centimetres, which means my radius is going to be half of that, which is 18 centimetres. We write down the formula for the surface area, which is surface area is equal to 4 pi r squared. So this is equal to 4 times by pi times by 18 squared, which is equal to 18 squared times by 4 times by pi, which is in this case equal to 4071.50407, continuing on. However, we want to round this to one decimal place, so that's where it's going to be. So our answer to this is equal to 4071.5 centimetres squared this time, because we're talking about area. So we're talking about area this time. So that's why this here is centimetres squared and not centimetres cubed. Okay, because we're talking about the area around the outside of this. That one there was example 3, I think it was. So get example 3 down and have a go at that one on the right hand side. Good, some people have got it already. So let's start going through it then. So my radius is equal to 5 centimetres, which means my diameter is equal to 10 centimetres. Surface area is 4 pi r squared, which is equal to 4 times by pi times by 5 squared. So let's work that out, which is 5 squared times by 4 times by pi, which is equal to, as everybody's put, 314.2 in this case, 314.2 centimetres squared. Brilliant. I've just rounded that straight with the calculator. Okay, so let's have a go at this next one then. To start getting this one down, I'll show you how to do this one here. So you do a arch on top like that, and then an oval on the bottom. So get that down. I'll give you a little second or so, just to get that down. So get this one down. Get this one down here. So, you might think, in a similar way to the volume, to find out the surface area of a hemisphere, you literally just chop it in half and you divide by base. And I'm going to explain to you why that's not the case and talk to you about what we need to do. And what I want you to do is I want you to imagine that that you have a football. So imagine you've got a football, okay? Imagine you've got a football, and imagine you've got a samurai, okay? And this samurai, he's got a knife, okay? And he throws the football up in the air, and he gets the knife and he slices the football in half. If you were to slice a football with a knife, the problem you'd have is when you split it in half, if you wanted to think about the surface area of this, you'd have the two, like the round parts of it, but the bits that would be missing to actually create a hemisphere are the bottom of this. So you'd have, if I was to cut a ball in half, so imagine this is the ball, you'd have this part here, but the bit that's missing would be the circle on the bottom. Okay, and it's really hard to imagine that. If we cut it in half, you'd have the curved area, which is what we're going to find out. But then you also have the circle on the bottom. Now, this is really important. So the way that we need to do this is find the total surface area of the hemisphere. Give your answer in terms of pi, which basically means that we need to do it non-calculator. So, the first thing I'm going to write down is what the radius and the diameter is. So my radius is equal to 5 centimeters. My diameter is equal to 10 centimeters, just out of good habit. So my surface, let's put total actually. Total surface area is equal to 4 pi r squared. The total surface area is equal to 4 pi r squared. So this is equal to 4 times by pi times by 5 squared. Now 5 times 5 is 25. Times by 4 is equal to 100 pi centimeters squared. Now this is the total surface area. So this is the surface area of a full ball. Now when I cut this in half and when I divide it by 2, it's not the same as the volume. If I divide it by 2, you're only getting the curved top. So my curved top is equal to 100 pi divided by 2, which is equal to 50 pi. So this here, I've just worked out the curved top part, which here I'm going to do in this bit. I'll highlight that so you can see. So my curved top is 50 pi, the area of the curved top, but the bit that's missing is the circle on the bottom. Now, you need to work out what the circle on the bottom is. So my circle area of the bottom, well, we know the formula for the area of a circle is pi r squared, which is equal to pi times by the radius squared, which is going to be 5 squared, which is equal to 25 pi centimeters squared. So we've got the curved top, and we've got the area of the circle on the bottom. So what we need to do with those is we need to find the total surface area by adding all of these together. And we do that by doing, so the total surface area of the hemisphere is equal to 50 pi plus 25 pi, which is equal to 75 pi centimeters squared. Now it's tricky that, because the majority of people in this will just find the surface area and divide by 2, and you won't get the full marks. You need to make sure that you are adding the area of the circle on the bottom as well. So get that down in your notes. Tricky, that one. So there's that question. Pop your hand up if you got that down. Brilliant. Super. Alright, so there's your answer, 75 pi. Brilliant, you got that right. Okay. We've got a couple more questions to go through, and then we've got some ones which are a little bit trickier. So this is a very classic question. And these ones here, they don't usually come up exactly like this, but they will come up as part of a harder question. So this one here is example 5, I believe. And it says that the volume of a sphere is 68,641. Work out the radius of the sphere. Now this one here is working backwards, isn't it? So we need to follow those 4 steps for working backwards, and they are: write down the formula, substitute in, simplify, and then work backwards. So I'm just going to write those down in case you haven't got them. We have done these before. So step 1 is to write the formula. Step 2 is to substitute in. Step 3 is to simplify. And the last little step, step 4, is to solve working backwards. So they're the steps that we need to follow for this. You write the formula down, you substitute in, you simplify, and then you solve working backwards. So we know that we're dealing with the volume, because it says that the volume of this is 68,641. So I'm going to need to write down the formula for the volume, which they've already given us here. So the volume is equal to 4/3 pi r cubed. So that's my step 1. Then I substitute in. So my volume was the 68,641, which is equal to 4/3 pi r cubed. Now this one here is tricky to simplify, but we can do it. What I'd suggest we do first, sorry, not tricky to simplify, it's tricky to solve. We don't really need to simplify this one because there's nothing on that right hand side we need to simplify, so we're just solving now. So the first thing I'm going to get rid of here is that divided by 3, and I'm going to do that by timesing by 3 and timesing by 3. So the first thing I'm going to do here is 68,641 times by 3, which gives me 205,923 is equal to 4 pi r cubed. So then we need to get rid of that 4 pi, so we need to divide by 4 pi. So if I divide both sides by 4 pi and divide by 4 pi, I end up with 16,386.8 is equal to r cubed. And the last little part of this, I need to get rid of that cube. Now I get rid of a cube by cube rooting both sides. So the cube root of this is r is equal to the cube root of the answer, which is I get 25.3998. Now remember, I need to round this to one decimal place, so I need a line after there. This one here is going to be equal to, my radius is equal to 25.4 centimeters, like so. 25.4 centimeters. So it's tricky, that, because there's a few steps we need to follow. We write down the formula first. We substitute in the values we know, which in this case is the volume. And then we work backwards to find out the radius. So have a go at that one on the right-hand side. Have a go at that one on the right. Okay. Let's have a go at this one then. So exactly the same thing. We write down the formula first, which is volume is equal to 4 over 3 pi r cubed. We write down what our volume is, which in this case is equal to this 41,000. So 41,113 is equal to 4 over 3 pi r cubed times both sides by 3. Which is 41,113 times by 3 is equal to 123,339 is equal to 4 pi r cubed. We need to divide both sides by 4 pi. So divided by 4 divided by pi is equal to 9,815.00 is equal to r cubed. So then the last little part is I need to cube root this. So if I cube root this, the cube root of this answer, r, is equal to 21.4 centimeters. Now you've got to be careful with this, because we've just worked out what r is, haven't we? That's what we worked out. But the question is actually asking for the diameter. Now I probably should have said this right at the start. So we've worked out the radius. But we actually want the diameter. So to find the diameter, I need to double this one. So times it by 2. So my diameter is equal to 21.4 times by 2, which is equal to 42.8 centimeters. Brilliant. So my diameter. Now be careful with that. They tried to trick us out, didn't they? They did try and trick us. I think I saw a few people writing 21.4. Okay, but be careful with that, yeah? You can see that actually they're asking for the diameter, so I need to double that at the end. The 21.4 is right for the radius, but not for the diameter. Okay. Here we go, we've got another question here. This is linking to what we did previously, which was volume of a pyramid. So, I'll show you how to draw this one. Very similar to the last time. I'd probably start with an oval like so, and then pick a point at the top and draw 2 lines up, like so, and then do your cone at the circle at the bottom here, and we're going from the centre to the edge, which is 4 centimetres. That's how you draw it, and the full height of this is equal to 14 centimetres. Now, the thing that makes this a little bit tricky is the fact that you've got to split it up into 2 parts. And what people don't realise is that when you've got the radius, it doesn't matter in a sphere where that radius goes, it's always going to be 4 centimetres. So the point I'm trying to make is that this here, from the centre of that hemisphere down to the bottom, is also 4 centimetres. Anywhere around that hemisphere is going to be 4 centimetres. Which tells me, this is the starting point, the vertical height of my cone, which is going to be 14, take away 4 centimetres. The vertical height of my cone is equal to 10 centimetres. And if you start to know that, then it becomes a little bit easier. Because we know that the volume of a cone is equal to the area of the base times by the height, all divided by 3. And the base in this case, because it's a cone, is a circle. And the hemisphere we've just been doing, so we find out the volume of a sphere and divide by 2. So let's do this one first. Let's find out the area of this circle, which is this part here. So my area of the circle is equal to pi times by r squared. R in this case is 4. So it's going to be pi times by 4 squared, which is equal to 50 points. Now I'm going to do it to a few decimal places first. 265 centimetres squared. So that's the area of the circle, but we're not trying to find the area of the circle, we're trying to find the volume of the cone, which is the area of the base times by the height divided by 3. So this is going to be the volume of the cone is equal to 50.265 times by the vertical height of the cone, which is 10 centimetres, and then divided by 3. So times by 10 divided by 3. So the volume of the cone is equal to 167.6 centimetres cubed, because it's the volume. Oh, there we go. It's working out. Don't know what happened there. So, yeah, I've just worked out the volume of the cone. I've worked out the volume of the full sphere by doing 4/3 pi r cubed. But then I needed to divide this by 2 to find out the volume of the hemisphere. And then the last little part is I need to add both of these together. So the total volume is going to be equal to 167.6 plus 134.0. So 167.6 plus 134 is equal to 301.6 centimetres cubed. Now that came up in there towards the end of the higher paper. It was only worth 3 marks. But we need to find the area of the cone, the area of the sphere, then divide it by 2. Knowing that the height of the cone is 10, I think that's probably the trickiest part. And then we can add them together. So there's your answer. So get that down.